Well, matter undergoes changes, and there are physical changes and there are chemical changes. When matter undergoes a physical change, only the state, solid, liquid, or gas, or the appearance of the substance is changed, but the composition is the same. So when we're talking about physical change versus chemical change, the key to being able to identify this is to look at or think about the particles and what's going on with the individual particles. So if the particles are changing, it's not a physical change. So if we think about a big hunk of wood, if we cut the wood in half, have we changed the log? Well, it's not as big anymore, right? We have two pieces and they're smaller. Are they each still made of the same substance, wood? Yeah, they are. So that would be a physical change, cutting something in half. If we take an ice cube and we melt it, are the water molecules still the same? Sure they are. Its state has changed. It's gone from a solid to a liquid. When water boils, I've got an illustration, a pot here and the water's boiling. Here we have water in the liquid state, the particles are very close together, and here we have it in the gas state. They're moving away from each other. But the particles, little Mickey Mouse heads here, are still the same. So anytime you have a physical state change, solid, liquid gas, etc., it's just a physical change. A chemical change is one where the composition does change. If we look at this nail, an iron nail, the original iron nail is composed only of iron atoms. They're arranged in this nice crystalline manner. When the nail rusts, it undergoes a chemical change, and oxygen gets incorporated in here with the iron atoms. And that changes the composition of the nail. It changes some of its properties too. It's not as strong anymore. If you take a rusty nail and try to pound it into a piece of wood, it might just break in half because rust is not as strong as the pure iron is. So we have this chemical change. Rusting of iron is a chemical change. Some more examples. Here we have dry ice subliming. You can buy dry ice at the grocery store if you're old enough. It's really fun stuff and it's really cold. The reason they call it dry ice, regular ice would be wet ice, I guess. When regular ice melts, it gets wet. Dry ice is solid carbon dioxide. It doesn't melt. It sublimes. It goes directly into the gas state, and so it doesn't get your sandwiches wet in the cooler. So that's why they call it dry ice. So here we have the carbon dioxide molecules as the solid. Here they're going into the gas state. The particles are still the same. It's a physical change. Here we have sugar dissolving. You put some sugar into a glass of water. Here are illustrations of the sugar molecules. In the sugar crystals, these molecules are all lined up very nicely. When you put the sugar into the water, the sugar molecules themselves don't change. They just separate and mix with the water. They form a homogeneous mixture. I really need to turn that Dropbox thing off. Here's propane gas burning. This is the gas you use in the gas grill in the backyard. So the propane burns. Here's the propane molecule. When it combines with oxygen from the air and burns, it produces carbon dioxide and water. These are not the same particles as we started with. It's all the same atoms. There's carbon atoms and hydrogen atoms and oxygen atoms, but they've rearranged. And so that's a chemical change. We also have properties. So we just talked about physical and chemical changes. Now we're going to talk about physical and chemical properties. A physical property is a property that is displayed or observed without changing the composition of the substance. So the smell of gasoline is an example. The mass of my Sharpie marker. If I take my Sharpie marker and I put it on the balance over there and weigh it, does it change what the Sharpie marker is made of? No, it doesn't change it at all. If I observe its color, if I measure its length, find its density, these are all examples of physical properties. The boiling point, the melting point of substances, also physical properties. A chemical property is one that the substance only displays when it changes its composition. So these are going to be chemical changes, also known as chemical reactions. So gasoline is flammable. When you smell gasoline, and I don't encourage you to do that very often, when you smell gasoline, the particles are still gasoline. But when you light a match and you demonstrate the property of flammability, the gasoline is no longer gasoline. It's been converted into carbon dioxide and water. The particles are changed. It's a chemical change. So things like corrosiveness, acidity, toxicity, flammability, these are examples of chemical properties. So here's a practice question. Determine whether each change is physical or chemical and what kind of property is demonstrated. So we have a copper wire is hammered flat. Is that change physical or chemical? Physical. Because when we smash the copper with a hammer, does it change the copper atoms? No. It changes their relationship to each other. It changes the shape of the copper, but it doesn't change what the particles are. So, does anybody know what the name of that property is?
Malleable.
Malleable. We say that copper is malleable, meaning it can be pounded flat. It's a physical property. A nickel dissolves in acid to form a blue-green solution. Chemical. Now, many times when things dissolve, like when sugar dissolves in water, when salt dissolves in water, that's considered a physical change. So this word dissolve could be a little misleading. To form. That's your clue. This is changing. It's doing this and it's forming something else. The nickel is no longer nickel atoms. It's being converted into nickel ions in the solution. So is that a chemical property or a physical property that nickel will dissolve in acid? It's chemical. If it's a chemical change, it's going to be a chemical property. Dry ice sublimes without melting. Physical. So sublimation is a physical property. Do you have a question? No. Yeah, they're too fast. A match ignites when struck on a flint. Chemical. So when the match bursts into flames, it burns. Anytime you've got burning, it's going to be a chemical change. Can you use that match again? No, that's a one-time deal because the substances have changed. It's a chemical property. A match, the property of igniting when struck with a flint is a chemical property. Any questions?